So in continuation, this is type 3 of our trigonometric function or trigonometric transformation of trigonometric formulas. You are now given type 3, the integral of tangent raised to n u du and the integral of cotangent n raised to n u du. This time, the exponents n should be now equal to a positive, odd, or even integers. I repeat, and trigonometric formulas under transformation type 3, the exponents n should now be equal to a positive, odd, and even integers. And when it is now a positive, odd, and even integers, you will then apply identities such as 1 plus tangent squared theta equal to secant squared theta, and 1 plus cotangent squared theta, which is also equal to cosecant squared theta. Knowing that, let us try to solve an example problem involving this type of transformation. You're now given an indefinite integral of tangent raised to the fifth y dy. Evaluate the given indefinite integral. Remember, the exponent should be positive, odd, or even integers. So given it is both positive and it is an odd integer, we can then apply the transformation involving type 3. This particular integrand is the same as tangent cube y times tangent squared y dy. Then we know that tangent squared y can be expressed as secant squared y minus 1 based on our applicable identities on this particular type of transformation. Basically, distribute your tangent cube to our parenthesis term dy minus the integral of tangent cube y dy. Then remember that the differential of tangent y is equal to secant squared y dy. So basically, meron na tayo ng term na yan dito. So we'll just have to introduce a correcting factor of 1 over 1 and basically cancel that term out and apply power formula to our tangent cube, which lead us to tangent raised to the fourth. So 3 plus 1 lang yan, raised to the fourth over 4. Simplify this one further. That is tangent cube, which is also the same as tangent squared y times tangent y dy. Where remember from our identities for this particular transformation, tangent squared is the same as secant squared y minus 1 times tangent y dy. Distribute our tangents. That is now tangent y secant squared y dy minus the integral of tangent y dy. Same condition. So basically, that's plus. That is now negative tangent. Mag-add lang tayo ng plus 1 dito. So that is now tangent squared y over 2 plus the integral of tangent y, which is now ln cosine y plus c. Pagsamasamahin lang natin yung ating integrated terms. That is now 1/4 of tangent raised to the fourth y minus tangent 1/2 of tangent squared y plus ln of cosine y plus c. Then that will serve as our final answer for this problem. Any question? So, eto ngayon ang ating first example. So, let's see. Kung walang tanong, diretso tayo sa second example. Number 2. Number 2, you're now asked to evaluate the indefinite integral of cotangent raised to the fourth x dx. It is now positive, also a positive even integer. So cotangent raised to the fourth x dx. We can express that again as cotangent squared x times cotangent squared x dx, di ba? Pwede rin ganyan. Such that cotangent squared x can also be expressed as cosecant squared minus x. Ay, minus ba yan? Squared x minus 1 dx. Distribute lang natin integral of cotangent squared x cosecant squared x dx minus the integral of cotangent squared x dx, right? Then we know that the differential of cotangent is simply equal to negative cosecant squared x dx. So meron tayong common terms. Mag-introduce lang tayo ng correcting factor equivalent to negative 1. Then apply tayo ng power rule dito. Okay? So that is now negative cotangent cube x over 3 for the first term. So okay na yan. Dito naman tayo. Simplify natin yan. That is now also equal to cosecant also equal now to cosecant x minus 1 dx, right? Distribute your antiderivative. Cosecant squared x dx minus this minus positive what? Dx. Okay? Ano susunod? The integral of cosecant squared x dx is simply what? Ano susunod dyan? That is now positive cotangent x. Then the integral of dx is positive x. Diba? Integral of cosecant squared x is negative cotangent. So negative is positive. Then plus your integration constant. So simplify. That is now 1/3 cotangent cube x plus cotangent x plus your integration constant. So yan lang po yung problem na yan. Number 3. What if you're now asked to evaluate the definite integral of cotangent raised to the 6y dy? Paano naman pag ganyan? We can also express this particular integrand the same as the product of cotangent raised to the fourth y times the cotangent squared y dy, right? Which is also equal now to cotangent raised to the fourth y of cosecant squared y minus 1 dy. Distribute ulit natin. That is now what? Cotangent raised to the fourth y of cosecant squared y dy minus the integral of cotangent raised to the fourth y dy. Alam na natin yan. That is basically the differential of cotangent is basically cosecant squared y. So power rule, that is now negative cotangent raised to the fifth y over 5. So integral, differential of cotangent, negative cosecant. Simplify this one, minus cotangent squared y times cotangent squared y dy, which is also the same as cotangent squared y times cosecant squared y minus 1 dy. Ganun ulit. Cotangent squared y times cosecant squared y dy. This is now positive. Yeah, positive dy. No. Positive cotangent squared y dy. Dito, this is simply what? Positive cotangent cube y over 3. Differential of cotangent is negative cosecant squared. So, negative 1 times negative 1, positive. So, power rule na lang yung natitira. So, cotangent cube y over 3. Then, this part here, cosecant squared y minus 1 dy. Distribute your integral sign. Cosecant squared y dy minus the integral of dy. The integral of cosecant squared y is simply negative cotangent y. Integral of dy is simply y plus c. Nag-ladder na tayo. Diba? So, meron na tayo final answer. Pagsamahin lang natin silang tatlo. 1/5 of cotangent raised to the 5th power y plus cotangent cube y over 3 minus cotangent y minus y plus c. So, eto na ngayon yung ating final answer for this problem. Question po. Hello?
None po, sir.
Yan lang po ang type 3 trigonometric functions. And susunod dyan is our transformation for trigonometric formulas type 4 and inverse trigonometric functions, and lastly integral by parts using formula number 16. Yung integral by parts, medyo masaya yung by parts. Medyo mahaba-haba pero merong shortcut. Then, inverse, ganun ulit. Inverse trigonometric formula, formula 14 and formula 15. Dalawa kasi yun. So, yan lang po for today, type 2 and type 3. 24 ngayon, no? Tignan ko po bukas, 11:30 to 1:30. May seminar kasi kami. So, kung wala ako sa Gmeet ng, let's just say, 10 minutes, pwede na po kayong mag-leave tomorrow.